everyone. Welcome back to Human Geography. Today we're starting Chapter 2 on population and health, really mostly on population. There's a little section at the end about health, but we'll get there. Really a fascinating topic for geographers to think about. There's a specific discipline called demography, which is about describing the characteristics of population, including population change, population growth, the characteristics of populations like the age of people in the population, the number of children that women have on average, all those characteristics that tend to happen as at a population level are described using the science of demography. So geographers are interested in population for a number of reasons. Today we're going to get through around section 2.5, so through the demographic transition. The textbook actually has a fairly long section here of thinking about population that gets into the theoretical, I guess, it's maybe not theoretical, but the forecasting or predictive worries that people have had about population growth. And I don't know that it grounds it as well as it could because it doesn't talk about the context in which those predictions were made. And so I want to put that first. I will circle back to the idea of thinking about population, maybe without as much detail as is given in the textbook. You're welcome, of course, to follow up on that and even read the sources that the book mentions in that section. But I want to talk about why population is important to our thinking about human geography, what kind of changes we've seen in population at the world level, the regional level, and even some local level changes in population at the country level at least, and what's driving all that. So that gets us through section 2.5, which is the demographic transition. Let's take a quick look at the state of the world population. Right now, there are almost 8 billion people on the planet. The forecast is for the world to cross the 8 billion threshold sometime in the next few months, sometime at the end of 2022 or early 2023. We're at 7.9 billion right now. If we look at where people are in the world, this is what's called a cartogram. So the cartogram is scaled so that the size of the country is proportionate to its population, not to its land area, which gets a really interesting map here, right? My head is really blocking the view of Indonesia. Let's get my head out of the way so you can see more of this wonderful map here. And by the way, our textbook has fine maps, but the scale on them is a little bit, the resolution on them, I should say, is not as good as I'd like. And so I'm using these excellent visuals from Our World in Data for most of the visuals in this presentation. And so that website is great as a resource to check out if you're curious to learn more about population, about economic development, about the differences in disease around the world. So Disease Geography is a great site for that too. Really a great website. Can't recommend it enough. Anyway, onto this cartogram. What we notice here is that Asia, if we see this little dividing line here showing us Asia versus the other continents, Asia has 4.5 billion. Africa has 1.2 billion. There are 711 million in all of Europe. And then North America and South America combined have just over 1 billion combined, so 587 million in North America and then 428 million in South America. So what should stand out to us right away is how massive Asia's population is. Over half the world's people live in Asia. And in fact, around a third of the world's people live in just 2 countries in Asia, India and China. We can divide this region though, because there are some really large countries that would be much larger in appearance if they weren't so overshadowed by India and China. So Pakistan has 201 million, Bangladesh 166 million, for example. If we combine Pakistan, India, and Bangladesh together, then we've got the South Asian population cluster, along with Sri Lanka down here as well. China plus the Koreas plus Japan and Taiwan forms the East Asian cluster. Notice here how tiny Mongolia is with its very small population, right? So this cartogram is quite interesting. Siberia basically disappears to this little thin line over here. That's the Asian part of Russia with 34 million people in it, right? It's not very big at all. And then we've also got Southeast Asia. So this cluster is Vietnam and Thailand, all the way over into the Philippines and Indonesia, including Malaysia. So that's quite another cluster as well. So those three main population concentrations, together with the rest of Asia, make up the overwhelming bulk of the world's population, more than half the world's population in just that one large landmass. Notice that Europe and Africa are relatively well represented compared to the Western Hemisphere. And so this is quite a stark contrast. We think of the Western Hemisphere as being large, but it is large in land area, not that populated. So these differences are interesting to us. And one of the things that probably occurs to you is, how did it get this way? What kind of processes led China and India to become so large and other countries to not become as large or to stay relatively small? Like, for instance, look at Canada here, right? So we'll get to that in a minute. I'm going to fast forward a little bit here to the idea of the EQ mean. And this is mentioned in this section of the textbook. The Greeks had this idea of the central Mediterranean being the just right place to live, and then places too far to the north were too cold, places too far to the south were too hot. And so, of course, you wanted to live where it was just right, which is ethnocentric, but that's typical of a lot of cultures. But the EQ mean is the area of inhabitants. It's the place where people live. And what we notice is that people have started in clusters a long time ago. And by the way, this evidence is all based on archaeological evidence. So archaeologists know about how many people there were based on traces of humanity from the past. And so the closer we get to the present, the more accurate it becomes, because we have more and more recent records, historical records, as well as actually written histories of a lot of these places. But what I want to focus on is this little one down here. My head is in the way yet again, so let's get my head out of the way. Let's look down here on this corner at the year 2000 map. And what we see here is a pretty clear pattern of those concentrations I mentioned to you. You see the South Asian cluster here, the East Asian cluster here, and then the Southeast Asian cluster is a little less clear, a little less distinct than those other two, but still there. It shows up on that cartogram better. And you see how not densely populated the Western Hemisphere is in contrast, and how even a lot of Africa, which does have over 1 billion people, a lot of Africa still doesn't have that many people. So there's a few patterns we can observe here, and the textbook I don't quite agree with what our textbook says. It does, I think, correctly point out that there's some areas like northern Canada or Siberia that are too cold for dense human habitation. It also points out that there are places that are too dry for dense human habitation, like Australia, like the Sahara Desert, like the Arabian Peninsula. There are also places that are too wet, which seems contradictory, but there's places that have so much rainfall that they're actually not ideally suited for human habitation. So, for example, where the cursor's centered here is over the Amazon rainforest. That is not that friendly to dense human settlement. Our book doesn't mention this specifically, I don't believe, but there are areas that are too high for human settlement. So the Himalaya mountains, for instance, right here, really stand out. The Andes are a little bit of an exception, but then the Rocky Mountains also tend to be a little bit too high. And you could argue basically in that case that too high isn't really too high, it's just too cold. So that's possible, it's too cold. The point of difference I have with our textbook is that our textbook mentions that some areas are too hot for dense human settlement, and that's really not true. There's not places that are too hot for people to live right now in great numbers. And look no farther than the Indian subcontinent. Look no farther than southern China. Look no farther than the Philippines. These areas are super hot in temperature and quite humid for much of the year. The areas that people don't live are hot and dry. And so the dryness is the factor there. There's not water available. So it's possible that with climate change and a warming planet, we will end up with areas that are just straight up too hot to live. but we haven't really gotten there yet in terms of our present settlement patterns. So really briefly, that's the ecumene, E-C-U-M-E-N-E, the area that people inhabit. And we notice there's some patterns where people tend to live in areas that have water available, aren't too cold, aren't too high, and aren't too rainy, aren't too wet. Here is a really powerful graph of world population for the last 12,000 years. Again, I'm going to repeat myself. The farther back we go in time, the less accurate our estimates are, but they're based on sound archaeological reasoning and evidence. Just they might be off by a factor of 10, right? Maybe 20%, maybe 50%, but they certainly aren't. It wasn't like there were 400 million and they say there were 4 million. So what we observe is that population growth was very slow until well after the time of Christ. So very incremental population change. In this period, this pre-industrial period, humanity was making progress across the globe, but barely beating the reaper, barely staying ahead of death. So population growth was extremely slow here. So the estimate from 10,000 BCE was 4 million. By the time of Christ was estimated to 190 million. So that's 10,000 years to get a gain of 185 million, 186 million. Notice then that between 0 and 1700, the population went from almost 200 million to 600 million. So that's much more rapid growth, right? Now, of course, it was on a bigger base, but we started catching up a little bit here. There's a little blip here in the diagram. Then there's a note that says it's the Black Death that took out a major portion of the world's population, right? So again, not trying to be too macabre about this, but again, emphasizing that humanity was really just barely keeping up with the Reaper during this time, with the Grim Reaper, right? Notice here, though, that between 1700 and 1800, something starts changing. Instead of this slow line or even a medium struggling line with some big dips, the line here starts to go up very rapidly. This coincides with, but not a coincidence, this line goes up caused by the advances of the Industrial Revolution. The move from a pre-industrial society to an industrial society had major advances for life expectancy. We started, for the first time in human history, we started getting ahead of death a little bit. Now, death still comes for us all, but we got ahead of death a little bit. And we started doing things like inventing better sanitation methods that made it harder for people to get sick, especially for kids to get sick and die young. We came up with rudimentary medicine, but more and more advanced medicine, like the development of antibiotics, for example. Part of that resulted in engineering that allowed for us to transport food from areas that didn't have enough, from areas that had too much to areas that didn't have enough to alleviate famine. It helped us invent techniques like food canning and food preservation that hadn't been done at an industrial scale, that allowed people to live even in times of shortage. And it created overall a surplus that allowed for people to live longer lives than they had before the Industrial Revolution. So notice that the line starts going up and it gets steeper and steeper. And so really quickly here, we can do the math. About 1 billion people in 1800. The next billion was 1928, so about 128 years to add 1 billion, from 1 billion to 2 billion. The next billion took 32 years. The next billion took 25 years. The next billion took 22 years. I hope in this context of extremely rapid population growth, you can understand how people were looking around and saying, is this sustainable? Can the Earth keep up with this massive growth of population? Or is it possible we might have too many people? So it was around this time, the 70s to 80s and even into the 90s period of extremely fast population growth, that a lot of people started saying, this is bad. This is something to worry about. This will result in a crisis. We're going to run out of food, or we'll run out of clean water, or we'll run out of fresh air, or we'll run out of oil, run out of energy resources because the Industrial Revolution that started this whole thing was based on fossil fuels, coal in particular, but later oil, right? So people started being very concerned about this rate of population growth because they didn't see it as sustainable. They were echoing the arguments of somebody who was living in Great Britain right here at the end of the 1700s, Thomas Malthus, who had an influential, at the time, book on population, is the name of his book. It was a treatise on population. And Malthus's book was all about how he noticed that the population was increasing really rapidly in England, in the British Isles. And he said, you know what, we're on an island. We're going to run out of farmland sooner or later. And the result that he predicted was catastrophe. He predicted that to get more farmland, Britain's masses of people, because it was growing so fast, would have to go to war to find more farmland. And you can't just take over farmland if there's people already living there, so it requires them to be removed or killed. And so he had this sort of apocalyptic view of what was going to happen because of this massive population growth. Now, interestingly, Malthus in the late 1700s was proven wrong by time. But then when people came along in the 70s and 80s and saw this massive population growth, they said, well, that was nothing. Now we have the same thing happening on a global scale, so maybe he was right. Those are called neo-Malthusian arguments, by the way. Anyway, other people said, you know what, maybe that's true, but honestly, what we see is an incredible ability of humans to be ingenious and solve problems and develop new technologies that increase food production, that increase the harvest from land we thought would be low harvest into making it much more productive. We have advances in the transportation and storage of food, and so human ingenuity will solve the problems, and will save the day. Esther Boserup in particular was the author mentioned in our textbook that had that view of the world and population growth. But it's still worth worrying about for some people to be thinking about whether we're going to eventually run out of some resource because of rapid population growth, or whether this is a sustainable world that we've got right now, almost 8 billion people, and we're heading towards more on. So that's the context of that discussion in our textbook in that section 2.2, I believe. But I want to move away from that for a minute because I hope you appreciate why people were worried about population growth, and some people still continue to be. But I also want to share that now in the 2020s, we're a little less concerned than we were because we've been observing something for the last several decades called the demographic transition. So that's where we're going to end up. Let's talk about the patterns that have gotten us there. By the way, Our World in Data has these maps as fixed maps you can download like this. They've also got live ones where you can go back in time and look at a country, and you can highlight individual countries and look at the trend over time. It's really amazing data presentation. It's really fun to play with. If you're a data nerd, you're going to really enjoy it. So I recommend it. Let's take a look at the components of demographic change. And this is another place where I'm going to deviate a little from our textbook and have a little stronger opinion on something than the author of this chapter, David Dorrell, has about the issue. Early in chapter 2, the author says something along the lines of, every place is different, and so the reasons for population change are always different. And I fundamentally disagree. I think there's pretty common causes to population change around the world. The exact circumstances of population change may differ country to country, sure, but there are overwhelming drivers of population change. So let's talk about the demographic equation really quick, which is what helps us decide whether a population is growing or shrinking. And by the way, when we talk about demographic change with respect to population, we're almost always talking about what we call natural increase or natural decrease. So population growing from within or shrinking from within. Immigration is another way by which populations can grow, or emigration, the movement of people out of a country, can shrink, but that gets wrapped up into the next chapter. And so A country's size is a function of both natural increase and immigration, but we look at one at a time because they're separate processes. So they are related for complex reasons. We'll get into that later when we get into chapter 3 as well. But let's take a look really quick here at the first component of demography, which is the birth rate. This number is per 1,000 people. And what we see here is that there aren't any countries on the map today that have a birth rate over 50 per 1,000. But there are some, especially here in landlocked portions of sub-Saharan Africa. So, for example, Mali, Niger, Chad, Central African Republic, Somalia stands out. These countries have birth rates that are very high in the 40s per 1,000 total people. We measure birth rates in the per 1,000 range because it gives us a really quick idea of the relative size of population change independent of the size of the country. So some countries have a lot of people and some countries have a few people, but we're interested in the rate of change between those two different sized countries. And pretending like each is a village of 1,000 people gives us a really quick way to measure, because a country that has a birth rate of 40 per 1,000 is obviously having a lot more kids than a country per person having a lot more kids than a country with a birth rate of 10 per 1,000. So it levels the playing field, so we pretend like every country has 1,000 people. That allows us to compare between populations of different sizes and see which ones are growing faster or not growing as fast relative to their own size. So we notice that Sub-Saharan Africa has a lot of high growth. A few countries here in Southwest Asia and into Southeast Asia, medium rates, as well as some parts of Latin America, medium rates. Notice there are low birth rates across all of Europe, a lot of Asia, East Asia in particular, down in Australia, New Zealand, and then a lot of the Western Hemisphere also has very low birth rates. So the total number of babies born is one part of the equation, and that's adding to the population every year. So this is 30 or 40 or 10 babies per 1,000 per year being added to the population. The other side of the demographic equation is the death rate. And this is the crude death rate. Now, I wish our world in data had this in the same ratio, but they don't. They have it as percent. So you need to multiply it by 10 to get the per 1,000 number, because percent is per 100. So this is 0 to 5 deaths per 1,000. This is 5 to 10 deaths per 1,000. This is 15 to 20 deaths per 1,000. Now, the scale goes all the way up here to 35 deaths per 1,000, but there's no country here that is that bright. As a matter of fact, you can see only one here that is in the higher than, I think that's the higher than 2% range, if I'm not mistaken. It's a little hard to tell which one's which here, but almost, yeah, that's right. That's the one. So every country in the globe except for one or two are below 20. And so really quickly, what we can see here, and then notice that the countries that had really high birth rates are still in the 10 to 15, maybe 20 range here, right? So really quick math tells us that every place in the world has more babies born, not every place in the world, but most places in the world have more babies born than people dying in a given year, which tells us that the population is increasing. So taking the births minus the deaths gets us to what we call natural increase or population growth rate. So here we have, again, in percentages. So you could do this per 1,000 if you wanted to, but thinking about it in percents pretty easy, especially if you've taken like a personal finance class. You can think about interest rates the same way, right? What we notice is that most places in the world are growing, either somewhat slowly or modestly. There are a few places in the world that are growing very fast. There's none anymore that are growing extremely fast. Greater than 4% is considered really, really high growth, but even 3% is quite high. So notice these places that had the really high birth rates also have the really high growth rates. And then, interestingly, we notice that there's actually quite a few places like China, South Korea, Japan, all of Eastern Europe, including Russia, Italy and Portugal get in here. Venezuela stands out. Cuba stands out. So a lot of places around the globe actually have natural decrease. There are more deaths than births in these places. It's easy to assume that that's because these places aren't healthy, but that's if we just sort of unpack that, that's obviously not true about places like Portugal or Italy or even Greece. Life expectancies are really long. People live really into ripe old age in these countries. So how is it then that they're losing population? The answer is because they are not having very many kids. And this is too big of a category to really show that up here. But if we look at the birth rates per woman in a place like Portugal or Italy, it is well under 2 births per woman. And I actually have that graphic here later on coming up here. So we'll get back to that. So these places have too few babies being born to counterbalance the older people dying. And that means that there's more deaths than births in a year, which means the population is shrinking from year to year. The Eastern Europe phenomenon is more complicated. It's not that people are living long, happy lives here and just not having babies. It's also economic stress, and a lot of the fallout from the post-communist era has led to really small family sizes and not that long of lives because there are long-term negative effects of the transition from communism to capitalism that haven't gone successfully. And not blaming one or the other, it was that the transition didn't happen very well, and there's not necessarily good governance in a lot of these places either. So the net effect is that there aren't many babies being born, and people are dying probably faster than they should, which is leading to this negative growth, if you will, this population decline. So that's happening here in places like Japan and South Korea. It's the same as places like Italy or Portugal. Japan, in fact, has the longest life expectancy on the planet. People live into their 80s with great regularity and much longer in a lot of cases, but they're just not having as many kids anymore. So this presents a real intense irony of demography, which is that the places that are the poorest, and hopefully naming these places, some ideas popped in your head about what some of them are like. The poorest places on Earth are having the fastest growth rate, the largest families, and the wealthier places are having the smallest families and the lowest growth rates, or even are decreasing in population, which is, we tend to think in a place like the United States that you should have kids when you can afford it, but the opposite of that is what's actually happening on the global scale. So let's talk about what's driving that. And the way we talk about that is using this model called the demographic transition. The demographic transition is a model of population change based on observations from mostly Northern and Western Europe, but increasingly from around the world, because we've been watching these populations change, measuring them, observing them, talking about them, studying population change for many decades now. And the demographic transition is interesting because it has been largely held up. It's been largely supported by the evidence, even as we observe more and more population change. There are 5 stages in the demographic transition model that our textbook uses. Some treatments end at stage 4, and you can see why here is because our world in data says yet to be seen for stage 5. But you can also say that stage 5 it has been encountered for some countries. So we'll get into that when we get to it here. But let's talk about the characteristics of these populations. I want to go into this in a fair bit of detail. And I realize that we are 30 minutes in right now. So if you feel like your brain is full and you want to pause, you can. And then come back in a minute, because I'm going to take probably 10 or 15 minutes more to really explain this model and why it's so useful. All right, here we go. So in stage 1 of the demographic transition, the birth rate is high and the death rate is high. This is what we consider a pre-industrial society. This is a society in which there is nothing being done to prevent natural fertility. So once a woman becomes able to conceive a child, it's not long before she starts having children, and then not much is done until she is too old to have more kids, or there's unfortunately really high maternal mortality in these societies as well. This was where most of society was in the world before around 1750, so before the Industrial Revolution. The whole world was here. The birth rate's really high. the death rate is also really high. And again, we're just barely staying ahead of death here. The Grim Reaper is sort of right there. One of the reasons the death rate is so high in pre-industrial societies is because a ton of kids don't make it. A ton of babies die before their first birthday. And when I say a ton, I mean like in some societies, it wasn't unusual to have death rates of 30 to 40% of babies dying in their first year. That sounds extreme, I know, but that was how tough life was in pre-industrial societies. If you were lucky, you might have a infant mortality rate down around 10%, right? So only 100 out of 1,000 would die in their first year. Maybe lower in a really elite class of a subclass of a society, but life was pretty grim and life was pretty tough. And in particular, people didn't have any medicine. There wasn't widespread knowledge of sanitation even in a lot of places. So there wasn't a lot to do except for just cross your fingers and hope or pray. And that wasn't very effective about saving people's lives. Notice here that in the move from stage 1 to stage 2, the birth rate stays high. And this is where I really want to deviate a little from that argument that the textbook makes here, that there's not much you can say about why different countries are in different population growth stages. The one commonality to keep in mind here is that in stage 1 and in stage 2, around the world, the birth rate is high because the primary role of women in these societies, and it doesn't matter what society we're talking about in terms of world location, the primary role of women in these societies is as wives and mothers. And so in that environment, the birth rate is up around 40 per 1,000, maybe 45, maybe 38, but very high, because fundamentally women get married young or start conceiving young and continue conceiving. Contraception, as we think of it today, did not exist. And this is early industrial society or areas that are starting to get medical technology in the 1900s from industrialized society. So the birth rate stays high. The primary role for women in this society is having kids and raising them. The death rate, though, drops because, as I mentioned already, industry, technology, medicine all contribute to saving lives, saving those kids' lives that were dying so rapidly before, and also helping people live longer into older age. So this death rate drops really rapidly, and this area that's filled in here in between, this blue area, is the natural increase. So when births stay high and deaths go down, there's a rapid population growth. And so we see this line here with the yellow underneath it going up rapidly because there's such a big difference between the change in the birth rate and the decrease in the death rate. The bigger that gap goes, the faster population growth goes. Now, the move to stage 3 from stage 2 is a really important one. The death rate continues to decline. Advances in medicine, advances in technology, advances in food storage systems or food provision or farming, all those continue. It's easier to keep people alive. It's easier to save lives. All that continues. The death rate goes down. The big change from stage 2 to stage 3 is a decrease in the birth rate. So something's changing here in the society where the primary role of women as mothers starts changing to be mothers and something else. And at the beginning it's small, but what we see is through stage 3 and then into stage 4, that becomes more and more influential. And the way to think about this is that in a stage 2 society, the typical or most common experience of a young woman would be to start getting pregnant in their teens and continue being pregnant and having kids, getting pregnant and having kids into their 30s or early 40s. That's a common experience in that society. And as we move into a stage 3 society and then on to a stage 4 society, we start seeing women engaging in paid labor outside of the home, We start seeing them delaying the onset of their first pregnancy until sometimes after their teenage years, early on, much more commonly after their teenage years, at the end of stage 3 and into stage 4. And then sometimes when we get into stage 4, even delaying the onset of their first pregnancy until their 30s, or not having kids at all, and instead choosing to go to school and work. And even if they do pause work to have a kid, work part-time, or sometimes even continue a career while having 1 or 2 children, maybe 3 children. So that is a dramatic change in society. That's not a technological change. That is a social change. And so I think you can say, yes, individual differences matter, but this is pretty consistent across societies, is that the status of women changes such that it's acceptable for women to do something other than have as many kids as possible. And I hope I'm not painting with too broad of a brush with that, but that's what the statistics are telling us here, right? Now, this is not to say that the role of a mother is treated the same in all of these societies. As a matter of fact, it can be quite complex to negotiate that for a lot of women today, especially if there's a lot of emphasis put on career building and motherhood, and that's really unfair in a lot of societies today. So I'm not trying to say one is better or one is worse, but it's a fundamental change. So notice what happens here to the natural increase rate as that birth rate starts to decline. The death rate levels off because sooner or later you get caught up and people are living pretty long, pretty healthy lives. You make incremental progress on the death rate, but the birth rate goes down pretty fast through this time. And so there is a decreasing natural increase. So natural increase is still happening, but it's slowing down in stage 3. Stage 4 is marked by, you see this slope here on population growth starts to level off because in stage 4, the natural increase starts approaching 0. It doesn't have to get to 0 to be stage 4. Obviously back here it's still growing, but it's slowing a lot and getting close to 0. So the United States today, our natural increase rate is somewhere around 1%, a little under 1% now. And that's considered stage 4, for example. Stage 5, as I mentioned, some people think as hypothetical or theoretical, but if we want to look for examples of stage 5, we can look for countries here where the natural increase rate has continued to drop, the death rate has stayed relatively flat, and so with the natural increase, sorry, I said natural increase, but I meant birth rate. If the birth rate continues to drop and the death rate stays relatively stable, then we have a decrease, a natural decrease in population. So that's what this coloration here is showing us. It's actually losing population. And that's what we've seen in places like Japan, for example, like South Korea, like China even today. We see the number of births not quite keeping up with the number of deaths. Now, the question marks are on here because Our World in Data actually does a nice job of summarizing this. They have a little page dedicated to it. There's a little bit of evidence that when countries get really developed, that is, when they get really well off with a fairly equal society and wealth well spread around, there's some evidence that the natural increase rate starts to tick back up into positive, very slightly positive, but a little bit. So this population decline stops and it goes to 0 growth or very slight positive growth. There's limited evidence for that so far, and this is about our population future, so we won't know. But notice that the place where we're heading here is either very low growth or slightly negative growth. That is why today, when people talk about population growth, they don't talk with the same sort of concern or urgency that they talked about it in the 1980s and 1990s. When I was going to school and learning about the geography of population, people were really trying to sound the alarm. People were saying, we don't know what's going on. This is out of control. There's so many people being born. We won't have enough resources. And the tenor of that conversation has really changed a lot, because what we see in the coming ages here of humanity is a stabilization of that population. Not to say it won't be without some problems, not to say that it will definitely be sustainable, but at least it's not going to happen at the same rate that people thought it might have. So I think I might have another slide here about that. Yeah, I do have a couple more slides. Let's talk about this now. We talked about the ideal. The nice thing about the demographic transition is it's this really nice model that makes sense, but then it also checks out that data tends to follow it. Now, these data, because they're real data from small countries, except for China, all the rest of these countries have small populations, the data are messy. They go up and they go down. But what we can observe is that in every one of these countries, we see a country in which the birth rate stayed high, the death rate started dropping, population increase started happening, and then the birth rate eventually came down to meet the death rate, and the total population stabilized. That happened in Germany. That happened in Sweden. Sweden is a little bit tougher to see. If you expand the graph so that it's filling the whole page instead of being squished down, it's a little easier to see that. But you can see here that the birth rate is much higher than the death rate for rapid population growth. The birth rate starts coming down here. There's a little bit of a boom, and then eventually it comes down again, and the birth rate and the death rate stabilize to be about zero population growth. Here in Chile, you can see that there were, again, you can see some messiness here around some booms and busts in the country's population. But again, you can see here the death rate starts falling, the birth rate stays high, and now the birth rate is falling and catching up with the death rate. So Chile in this graphic, this ends in the mid-2010 somethings, it looks like. Chile is now late stage 3, early stage 4, because that trend has continued and they're very close together. All right. And so we see this again and again. Mauritius here has this nice pattern where this is stage 1, where the birth rate and death rate are really high. Birth rate stays high, death rate drops rapidly, population growth goes up during that time really rapidly, and now the birth rate is finally coming down stage 3 and then approaching the death rate stage 4. So pretty cool that we've seen this pattern repeat itself again and again in very different contexts, right? Very different groups of people, very different historical settings, like the colonial history of one place versus China's very long history, but we've seen the same pattern repeating itself again and again. A couple observations about that. One is that the demographic transition, is, as far as we've seen, doesn't go backwards. There's nothing that pushes a country, or ever has pushed a country, back from stage 3 into stage 2, or back from stage 2 into stage 1, although nuclear war would do that potentially, right? So when you read a dystopian novel or see a science fiction movie about an apocalypse, then that's stage 1 again. But we don't consider that too seriously in demography. I guess anything's possible. Looking into the future then, when people were really panicking in the 60s, 70s, and even in the 80s, we had these really high growth rates. This purple line on here is the population growth rate. And the higher the rate, the steeper this line was getting. But then by the 20 teens, we started noticing that it was dropping a lot. Actually, by around 2000, we noticed it was dropping a lot. And we said, oh, well, that was bad in terms of rapid population growth if we were worried about sustainability. But it's on the way down. And then here we are in 2019 with world population growth at just over 1%, when it was over 2% in 1968. So it's growing now half as fast as it was at its peak. And that's definitely not as fast, right? That's a lot lower growth. Now, 1% on 7 billion people is not that different of 2% of 4 billion people. So we're still going to add some billions to the planet. But the projections here are from the UN, the United Nations, that's concerned with this sort of like modeling and forecasting and the like. And what they're forecasting is around 10 billion people by 2050, and then a leveling to around 11 billion people by 2100. So that's actually quite slow. Adding a billion people in 50 years is much slower than the growth that we saw in this period. And they're forecasting that around 2100, that there will be enough countries in population decline, and the countries that are growing really fast now will have transitioned to stage 4, that world population growth will be around 0 by the year 2100. So people, again, are less worried about the rapid nature of population growth when we see this trend happening around the world. A couple things to think about, though, with these changes in population is that the population growth has happened in a lot of places. There are some places that are growing really fast, and the places that are growing really fast versus places that have finished growing really fast have different sorts of problems or different sorts of challenges. One of these is the youth dependency ratio. This is the ratio of people younger than age 15 to the working age population. You can see in these countries here in Central Africa in particular, also Afghanistan stands out, then a lot of areas across Central Asia and some places in Latin America have really high ratios of really young people under age 15 to the working age population. The argument for this ratio, why this number is created, is because we generally think in a country like the United States that kids up to age 15 should be in school so that they can get training and knowledge so they can be a more productive member of society when they get to the working age, which is that age 15 to 64. Now, the textbook author here points out that in a lot of these countries, kids do work when they're in their teens. And I don't know that that's okay. I don't know if we can justify this not being a concern, because kids working at a menial job at age 12 or 13 means poor economic prospects for the future. And so those kids needing school or should being in school, even if they're not, it represents a challenge to the country. And now notice that this is 80% of the population, right? Like so if there's 100 people that are age 15 to 65, there's 80 kids that are under age 15 for every 100. That's what we're saying. That's a huge number of kids. And these places that have these high youth dependency ratios don't have the economies to put all those kids into quality schools because schooling is expensive. And so not only just schools, but also how do we build housing? How do we provide jobs for that many people coming into the workforce? All of these are really big structural challenges to the economies of these countries' futures. One answer, by the way, about what do all these young people do is they migrate. They move to places that have slower growth because there are fewer kids coming into the workforce as young adults because they don't have such a high dependency ratio. So there's a snapshot into chapter 3 for you already. The countries that have already encountered rapid growth and are now slowing, that are in stage 4 or stage 5, have the opposite problem. They have a high old age dependency ratio. So this is the ratio of people older than 64 relative to that working age population, age 15 to 65. And again, what we notice here is that there's some countries that are very high in this ratio. Not as high as the young dependency ratio, the youth dependency ratio, but still something like 50%. So for every 100 people of working age, there's 45 or 50% of the population, of that population, 45 or 50 per 100 in that old age group. This is a different problem because at the end of life here, these people have their own expensive needs, in particular medical care. And that's a challenge, especially when the generations coming up are not as large. And so that makes this dependency ratio worse. Japan in particular is in the middle of this. You can see here that they are the highest on that dependency ratio, but there's a lot of places in Southern Europe that aren't far behind Japan, Italy in particular, but also Greece is heading that way. And it's going to be a challenge for the future of these countries, is how to take care of all their elderly people as they get older and older, as life expectancies lengthen, and we keep having expensive medical technology to keep them alive. If we combine the two, the age dependency ratio of both people younger than age 15 and older than 65 relative to the working age here, you can see that there's some countries that are really high on both. And so notice there's some countries on this chart that have more than 100%. That's because if you take the number of people who are young, there's for 100 people aged 15 to 65, there's more than 100 below 15 and over 65. So that's telling you that the people who are supposed to be building the economy and paying taxes and developing things are going to have to do a lot to support those people on either end of the age spectrum. I believe that's all I have. That's all I have for now. I hope that was educational, informative, maybe a little thought-provoking, and that it's made you think differently about the way population growth happens why it happens, where it happens, or where it is happening, and has happened, and why it's fascinating as a geographer to think about changes in population. I will follow up with the next lecture on population futures a little bit more, talking about sustainability and the geography of health with respect to population. Thanks so much.